Okay, so let's start 6.12 question. The question is explain why the dipole moment of chlorobenzene is lower than that of cyclohexyl chloride, and all these are give reason type of questions. So give reason questions are also very favorite of examiner. Let's start solving one by one. The first is they're talking about dipole moment of chlorobenzene is lower than that of cyclohexyl chloride. So first thing you should know what is dipole moment. Dipole moment we denote by this, and Q multiplied by D is the formula, charge into distance. Now let me show you example of dipole moment. For example, hydrogen is here, oxygen is here, oxygen is here, hydrogen is here. So this is a water molecule formula. We know oxygen and hydrogen, which one is more electronegative? Oxygen, and hydrogen will get positive. Because of this, electron will shift more towards oxygen. Same thing will happen to this bond. Because of that, oxygen will get a double negative charge and hydrogen will get here positive. Now if you see, this is also electrons also going here, this direction is electrons are going here. So overall the electron will go to this place. So this movement of electron towards one of the side because of more electronegativity is known as dipole moment. So they are asking chlorobenzene. So let us draw chlorobenzene. So this is our chlorobenzene over here, is having lower dipole moment as compared to cyclohexyl chloride. Cyclohexyl chloride is just, you have to draw the same thing without the double bond structure circle in here. So this is cyclohexyl chloride. So why dipole moment of chlorobenzene is lower as compared to cyclohexyl chloride? This is the question. Now where is the answer lying here? See, remember dipole moment basically depends on the polarity. Okay. Now let us see this carbon and this carbon. If you get the difference between these two carbon, what is the difference between these two carbon, you will understand what is exactly the meaning and difference here. So if I draw this benzene properly with and the double bonds, I will put it like this. If you see, this carbon is sp2 carbon, and this carbon, there is no double bond, is sp3 carbon. And in the lectures we have already discussed that sp has more electronegativity than sp2 carbon, and sp2 having more electronegativity than sp3. Why does it happen negativity? Okay, this happens due to percentage of s character. If you see percentage of s character in sp, if 100 rupees divided into two parts, it will be 50%, and here it is 33.3%, and here it is 25%. More the s character, more the electronegativity. That means in case of this carbon is very much electronegative. So will it allow the electron to go from here to chlorine? Think about this chlorine and carbon bond. This carbon also loves electron, right? Because it is sp2. So do you think it will allow chlorine to shift the electron towards himself? He said, no, I also want electron. Chlorine say, I want electron. He said, because of this, the polarity, which is delta negative and delta positive, will be not that much. Because of this, what will happen? The dipole moment will be very less. But here the carbon is sp3, so it does not love electron as much this carbon loves. Are you able to understand? So here carbon and chlorine, even though carbon is having little bit s character, but it will not force so much chlorine to give electron to me. So the most of the electron will shift towards chlorine, so there will be little more dipole moment as compared to this. So I hope the concept is clear. So let me just tell you the exact answer what you will write. So you will draw this structure sp2 sp3. You will write sp2 hybrid carbon in chlorobenzene is more electronegative than sp3 hybrid carbon in cyclohexyl chloride due to greater s character. Thus, carbon atom of chlorobenzene has less tendency to release electron to chlorine than carbon atom at cyclohexyl chloride. So the dipole moment of chlorine is less. This I already told you. And so chlorobenzene is less polar than the second. So this is your ideal answer. So I hope you understood the first one. Let's go to the second question. Alkyl halide, though polar, are immiscible with water. So you know that already we are having this general knowledge with us that anything, if you want to dissolve in water, you know water formula is O, H, H, like this. Yeah. One more water molecule can take O, H, H. If you see, this oxygen is having negative, this is having positive, this is positive. So water is a polar molecule, and in miscibility the rule goes like dissolve like. That means if a polar molecule you want to dissolve in a polar molecule, yes, they will be getting dissolved very easily. So they are asking why alkyl halides, even though they are polar, are very much immiscible in water. Just now the rule says like dissolve like, right? For example, if I want to dissolve NH3. NH3 is a polar molecule, right? NH3 plus. So it will get dissolved, right? Because it is polar, water is also polar. But why not alkyl halide? If you see, alkyl halide is RX, CS3Cl, CS2CH5Cl, like that. Fluorine is more electronegative, it is having negative charge, this is having positive charge, so it is also polar. So as per the law, like dissolve like, it should get dissolved in water. Then they're asking why it's not getting dissolved. So for that, the one reason, let me tell you. Now, if you see, this oxygen is negative, this hydrogen is also positive, this oxygen negative. Between water molecules, there is a bonding. This is known as hydrogen bonding. Which bonding? Hydrogen bonding. If any molecule, suppose this NH3, want to get dissolved in water, they should have that much energy to break this hydrogen bond and get themselves replaced here. If NH3 can do that, it will get soluble in it. But CS3Cl does not have that much power to break this very strong hydrogen bonding which is present between the water molecule and replace that hydrogen bonding and place themselves in between. CS3Cl here cannot place themselves, so they are not having this capability to break this hydrogen bond and come in place of it so that it can get solved, dissolved in water. So that is the reason alkyl halides are not soluble in water. So ideal answer you will write in this way: alkyl halides are polar molecule, therefore their molecules are held together by dipole dipole interaction. The molecule of H2O are held together by hydrogen bond. Just I told you hydrogen bonds. Alkyl halide molecule, what is the dipole dipole interactions? For example, here positive, here negative. Okay, here another molecule, positive, negative. So this interaction is known as dipole dipole interaction. Okay, since it is no hydrogen here, so there is no hydrogen bonding, we'll call it here. Since the new force of attraction between water and alkyl halide molecules are weaker, that means this and this water, they are not able to, attract or break that hydrogen bonding. Already existing alkyl halide molecules and water. So alkyl halides are not able to break their bond. Hydrogen also are not able to break this bond, hydrogen bonding between each other. So what happens? First of all, alkyl halide is not ready to leave each other, and then H2 also is not ready to leave each other. The new bond what they wanted to make does not have that much energy first to break this old bond and then to create a new bond. Therefore, alkyl halides are immiscible, not soluble in water. So, alkyl halides are neither able to form hydrogen bond with water nor able to break the hydrogen bonding network of water. So, this is the ideal answer you are supposed to write. Let's go towards the third question. Grignard reagent should be prepared under anhydrous. Many times this question has come. Anhydrous means there should not be any water when you are preparing it. Now, what is the meaning of Grignard reagent? RMGX. Yeah, this is your Grignard reagent. If any water molecule comes, what will happen? Let me tell you. We know that Grignard reagent, this is having which sign? Negative. This is having positive sign. If a water molecule comes, water molecule breaks from H plus and OH minus. What happens? This positive will get attracted toward R and MgX will take away the OH. If water molecule comes in contact, RH, which is a alkane, get very quickly formed, and because of this, what happens? Grignard reagent does not remain as Grignard reagent. So because they are very reactive, they react with the moisture or water present anywhere and make alkane. This is the reason it has to be prepared in anhydrous condition. So the ideal answer you will write it: Grignard reagent must be prepared under anhydrous condition because they are highly reactive and react instantly with water or moisture to form inactive alkenes, because alkenes are not reactive that much, destroying the reagent. So the reaction you will write here is RMgX plus H2O gives RH plus MgOH. So I hope you understood. Thank you.